Lesson 17 is on rounding and estimating, which should be quite a bit of review for people. The main thing to remember is that when you are rounding, anytime you cut a number off rather than writing all of the decimals or all of the digits, you need to make sure that you round correctly. You don't just cut it off. If the number after what you're cutting it off at is 5 or more, the number you're cutting it off at rounds up. So if I have 34.963 and I'm going to round it to this digit, I'm going to make that an 8 just for ease, 0.863, and I'm going to round it to this digit here. I'm going to cut it off, but I have to look at this number. Since this is a 6, that's going to make the 8 round up, so it's going to be 34.9. If instead I was rounding it to the 6 digit, so I was at 34.863, and it said round it to 2 decimals or to the hundredths place, means I'm going to cut it off here. I have to look at this number. Since that number is less than 5, the 6 stays as it is, and it would be rounded to 34.86. So there's your mini lesson on rounding and estimating. When you're estimating, it's a really good way to check if your answers are reasonable, which we'll have some problems on that in this homework assignment. In the orchard, there are 10 rows with 12 trees in each row. How many trees were in the orchard? This is an equal groups problem, which we learned in lesson 4. And in equal groups, you have the number of groups, which is 10 rows in this case, times the number in each group, or the number in each row. And 10 times 12 is 120. 1 times 12 is 12, and then you put the 0 on at the end. 120 trees were in the orchard. At 8 a.m. it was 57 degrees, and at 1 p.m. it was 72 degrees. How many degrees did the temperature change between 8 a.m. and 1 p.m.? This is a comparing problem from lesson 3. And in comparing, you take the greater number, which in this case is 72, minus the smaller number, which is 57, and that gives you the difference. Oops, 57, excuse me. That gives you the difference, or how much it's changed. Well, 57 plus 5 would give me 62, and then 10 more would be 72. So it changed by 15 degrees Fahrenheit between 8 a.m. and 1 p.m. Write a sequence of numbers with 1 as the first term and a constant difference of 2 between terms. So we have our bracket. So if I'm going to start with 1, and I'm going to have a difference between the terms of 2, that means I'm adding 2 each time. So 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, and so on. Brandon said that 48 yards is equal in length to 4 feet. Explain why his statement is unreasonable. Well, one thing that's unreasonable about this is that yards are bigger than feet. And right now what it looks like is that feet would be bigger than yards because there's fewer feet in his estimate than there are yards in his estimate. So one thing you could say is yards are bigger than feet, so the length in feet should be longer than the length in yards. There are 3 feet in each yard. And then it says 48 yards is equal to how many feet? So if I have 48 yards over 1, and I want to convert it to feet, the yards needs to cancel out, so it goes on the bottom. And then 3 feet on top. Yards cancels out, I'm left with feet, so I know that I'm going to do 48 times 3. So 8 times 3 is 24. 3 times 4 is 12, plus 2 is 144. This makes sense because we said that once we got it into feet, it should be bigger. 144 is bigger than 48. In the simplify section, remember, we're not just reaching for the calculator. The point is to be able to do these things in your head. So first it says 11 squared. Well, 11 squared means 11 times 11. And the 11's trick doesn't work once you get past into the 2 digits. So what I would look at is 11 times 10, and then I'd have to add on one more 11 because I'd only have 10 11s. 11 times 10 is 110, and then I'd add on 11, which is 121. Well, conveniently, in the next question, they ask us, what is the square root of 121? Square root asks the question, what number times itself gives you the number underneath the radical or the root sign? Well, we just found out that 11 times itself equals 121. So the square root of 121 is 11. In number 7, we're adding fractions. When we add fractions, we need to have common denominators. Right now we have 2 and 4. So looking at this, I know that I can, 2 is a factor of 4, so I can convert or rewrite 1/2 in terms of fourths instead. So to go from 2 to 4, I multiply by 2. Whatever I do to the bottom, I have to do to the top. So 1 times 2 is 2. So I'm going to replace 1/2 with 2/4. They are equivalent. Now when I add fractions and they have a common denominator, I add the numerators, or the top number. 2 plus 3 is 5. And the bottom number stays the same. The denominator stays the same. So I have 5/4. So what 5/4 looks like is I have 1, 2, 3, 4, and then I have one more. So 1, 2, 3, 4, 5/4. Well, this right here is 1 whole, and then I have 1/4 left over. So 5/4 is 1/4. One and 2/3 plus 5/6. Since I'm adding and I have a mixed number, what I'm going to do for now is ignore the 1, and I'm going to deal with the 2 fractions. So I need to get them to have a common denominator since I want to add them. So I'm going to turn the 2/3 into something over 6 because I know that 6 is a multiple of 3. So to get from 3 to 6 by multiplying, I multiply by 2. So then I do 2 times 2 is 4. So 4/6 is the same thing as 2/3. So I'm going to rewrite that. So I have 1, and then on top of that I have 4/6. Whenever I have a mixed number, I can write it as the sum of the 2. Sorry, it shouldn't say 4/4, it should say 4/6. I can write it as the sum of the whole number and the fraction. And then I'm also adding on 5/6. So the first thing I'm going to deal with is the fraction parts right here. Since I have a common denominator, I can add those. So I still have my 1, and then 4/6 plus 5/6. 4 plus 5 is 9, and then the denominator stays the same. So I have 9/6. So out of the 9/6, I can take out 6/6, which is 1, kind of like we did over here with the 4/4. And then I'll have 3/6 left over. So this is 1. 1 plus 1 is 2, and 3/6. And then I would recognize that 3/6 is actually half of 6. 3 is half of 6, so instead of writing it as 3/6, I would reduce it and say 2.5. Justine will fence a rectangular piece of land that measures 15 yards by 18 yards, then lay sod within the fencing. Find the length of fencing and number of square yards of sod she will need. So if I have 15 yards by 18 yards, that means that the perimeter is how much fencing she'll need around the outside, which is 15 plus 15 plus 18 plus 18. 15 and 15 is 30. 18 and 18 is 36. 30 and 36 is 66 yards of fencing that she'll need. Then, to figure out how much sod, we're going to calculate the area. So we're going to multiply 15 and 18. Well, 15 times 15 is 225. We've done that before. And then I'd need 3 more 15s. Because 3 plus 15 is 18. So 3 more 15s is 45. So I have 225 plus 45. 25 and 45 is 70. So 270 yards squared. When I do area, it's the units squared of sod. It says express with exponents. So when I see multiple numbers or variables of the same being multiplied, I'm going to use an exponent instead. So the only multiples that I see are the 2 x's here. So I would rewrite that as 5x squared. The 2 means there's 2 of the x's being multiplied. Y. In B, I have 2 x's and 1 6. So 6x squared. And then I have 3 y's. So y cubed. In 11, we're supposed to compare the numbers. So we have the square root of 100. The square root asks the question, what number times itself gives me 100? And hopefully we know offhand that 10 times 10 is equal to 100. So the square root of 100 is 10. And 10 is greater than negative 10. Letter B, we have the square root of 25 and the square root of 36. Well, one thing right off the bat is the number under here. You can compare individually. Since 36 is bigger than 25, you know that the square root of 36 will be bigger than 25. But we could also go through and actually figure out that the square root of 25 asks the question, what number times itself equals 25? And that's 5 times 5 equals 25. So the square root of 25 is 5. And then we would say what number times itself equals 36. And 6 times 6 equals 36. So The square root of 36 is 6, and 6 is greater than 5. Solve by inspection means look at it and see if you can figure out what number would have to go in place of the variable, x in this case, to make the equation work. So 5 times what number gives me 45? Well, 5 times 9 gives me 45, and then I can check. 5 times 9 equals 45. Check. Number 13. What number divided by 12 equals 3? Well, if I count by 12s 3 times, 12, 24, 36, it seems like 36 would be correct. So 36 divided by 12 equals, so if I count again by 12s, 12, 24, 36, I get 3. So that one works out. This says, what number plus 7 gives me 15? Well, 8 plus 7 gives me 15. So 8 plus 7, does that equal 15? Yes. And then the last one, number 15, what number, when I take it off of 18, so 18 minus what number gives me 10? Well, 18 minus 8 should give me 10, and we double check. 18 minus 8, 8 minus 8 is 0, 10. So 18 minus 8 equals 10, check. In number 16, it says select an equation from problems 12 through 15 and write a story about it. Okay, so I'm going to give you an example. I want you to make up your own, maybe pick a different one. So I'll choose number 13. We can say that a class of students is going on a field trip they take vans that seat 12 people each. How many total people went on the field trip if they took, if they needed 3 vans. So 36 people divided by 12 people per van gives us 3 vans. So that's an example of a story. I want you, if you want points for this, to write your own story, not using number 13. So you can use 12, 14, or 15 in your story. Number 17, evaluate. The perimeter equals 2 times the length plus the width when length is 7 and width is 5. Perimeter is 2 times the length is 7, width is 5. That means 2 times 12, which is 24 inches. Perimeter uses the same units as the length. Write the prime factorization of 90. So I'm going to use the space down here. So I have 90. Two numbers that multiply to give me 90 are 9 and 10. Two numbers that multiply to give me 9 are 3 and 3. Two numbers that multiply to give me 10 are 2 and 5. 3, 3, 2, and 5 are all prime. So the prime factorization would be 2 times 3 times 3 times 5. And they want us to use exponents for repeated factors. We have two 3's, so we would have 2 times 3 squared times 5. Patrice has 18 square tiles that she will lay side by side to form a rectangle. Name the dimensions of 3 different rectangles she can form. So basically what they're asking is what are factors of 18? And so one factor group is 1 by 18. So she could have a big long rectangle that is 1 by 18. 1 tile by 18 tiles long. She could have a rectangle that is 2 by 9. Tiles long. Or she could have a rectangle that is 3 by 6 tiles. Use the following information that answers problems 20 and 21. For 2 weeks, Destiny recorded the number of red lights at which she had to stop between home and school. These numbers are listed below. And the mean, median, mode, and range of the data. So the first thing that I do typically is put them in order because I'll know I'll need to do that for the median. So I have 2, 2, and then 4 3's. 1, 2, 3, 4. 2 4's. A 5. And a 6. So I have 10 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I did something right. I at least have the number of numbers I'm supposed to have. So to find the mean, I'm going to add them all up and divide by how many there are. So I have 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total numbers. 2 and 2 is 4. 4 3's is 12. 2 4's is 8. 5 and 6 is 11. 4 and 12 is 16, and 8 is 24, and 11 is 35. And I have 10 total numbers. When I divide by 10, all I do is I take the decimal point and move it one place over. So 35 divided by 10 is 3.5. So my mean is 3.5. The median is the middle number. So I go 1 off of each side. So 1, 2, 3, 4, and then 5. Well, since either side is 3, the median is also 3. And you can check that if you want. You would do 3 plus 3 is 6, and then you do 6 divided by 2 is 3. The mode is the number that repeats the most. There are 4 3's, which is more than any other number. So the mode is 3, and the range is the largest number, 6, minus the smallest number, 2. So the range is 4. Which measure would you use to report the number of stops that Destiny most frequently made? Well, frequently tells me that we're going to use the mode, because that's the number that occurred the most often. That was the most frequent. So I would say the mode of 3. Then we're going to, in number 22, rearrange the numbers to make the calculations easier. What property did you use? What is the sum? So the first one that I'm going to do is I see something that ends in a 7 and I see a 3. And I know that 7 and 3 are going to add up to something that ends in a 0, which makes my calculations easier. So what I'm going to do is I'm going to switch the places of the 28 and the 3. And I can do that because of the commutative property, which says that order doesn't matter if I'm adding or multiplying. Then I'm going to add 17 and 3, which is 20. And then 20 and 28 is 48. '23 says graph these points on the coordinate plane. You don't have this graph in your packet, so feel free to do some on some blank space on the back side of your worksheet to make your own little graph. Also, you can download this particular format of the worksheet off of Facebook, so you can look for that if you would like to have a copy of the graph section. Remember, when we have coordinates, the first number is x, which is side to side. The second number is y, which is up and down. So 4 means I go over 1, 2, 3, 4 places. And 0 means I don't go up or down. So the first one, 4, 0, is right here. Then -2, 3 means I go to the left on the y, 2 places, 1, 2, and then 3 means I go up 3 places, 1, 2, 3. So this is the point -2, 3. And then we have 0, -7 halves. And 7 divided by 2 would be 3.5. So this is -3.5. So I have 0, which means don't go left or right at all. And then -3.5 or -7 halves means go down 1, 2, 3 and a half. So -0, -7 halves is that point. Then it asks the question, which appears to be farthest from the origin? So just by looking at this, it looks like 4, 0 is farthest. We know that this spot right here is only 3.5 away from the origin, which is that point right there, 0, 0. And then this one doesn't quite look, -2, 3 doesn't quite look as far away as 4, 0. Find the perimeter of a rectangle with vertices -1, 2. So again, you don't have this graph paper in your packet, but you can do it on the back side of your worksheet, or you can download this worksheet from Facebook. Find the area and perimeter of a rectangle with vertices at -1, 2. So again, we have our x is side to side, our y is up and down. -1 means go over to the left 1, and then 2 means go up 2. And then we have 3, 2. This is one vertice. 3, 2 means to go to the right 3, 1, 2, 3, and up 2, 1, 2. 3, -5 means go to the right 3 and down 5. 1, 2, 3, 4, 5. And then the last corner is -1, means go to the left 1. -5 means go down 5. So they told us that it was a rectangle, and thank goodness that the shape that we drew in the end looks like a rectangle if I connect the dots. I have a rectangle. And now it asks us to find the area and perimeter. So now I have to figure out how long is each side. And I can do that by counting the squares. So 1, 2, 3, 4 squares on the short side. 1, 2, 3, 4, 5, 6, 7 squares on the long side. So to find the perimeter, I would add up those sides. P equals 4 plus 7 plus 4 plus 7. 4 and 7 is 11. 11 and 11 is 22. And when we do it on graph paper, we don't really know what the units are, so typically we just write units. And then to find the area, we're going to take 4 times 7. 4 times 7 is 28. And then again, units. And since it's area, it's units squared. Write these numbers from least to greatest. Well, I look through the numbers and there's no negative, so I know I'm going to start with 0. And then I look, 1.3 is more than 1. 4/3 is more than 1 because the numerator is greater than the denominator. And 1 and 1/12 is more than 1. So the next two numbers are 3/4 and 1. 3/4 is less than 1. And then 1. So now, if I look at these, 1.3 and then 4/3. Well, 4/3 I know is 1 and 1/3. So looking between 1 and 1/3 and 1/12, I know that 1/3 is going to be bigger. If I think about eating a pizza, I'd rather only share it with 3 friends because I'll get more than if I share it with 12 friends. So 1/12 is smaller than 1. 1 and 1/3 is bigger than 1 and 1/12. Now I'm going to compare 1 and 1/3 with 1.3. 1/3 is one of those fractions that you should just know what it is as a decimal. 1/3 is the decimal 1.333 repeating. And since it has numbers past that first 3, it's bigger than 1.3. So 1 and 1/12 is next. It's smaller than 1 and 1/3. And then 1.3. And then the biggest is 4/3. Which is a better discount? The price of $20 reduced by 30%, the price of $20 reduced by 1/4, or the price of $20 reduced by $4. So one way to do this is to compare the percents. So 1% that you should know offhand is that 1/4 is 25%. So right away you can see that 30% is bigger than 25%. So 30% would be a better discount. Another way that you could do it is to compare the dollar amounts. So 30% of 20 means that we have 3 10%, and 10% of 20. So if I have $20, I'm going to take that decimal point for 10%. I move it one place to the left. So 10% of $20 is 2. And I need 3 of them to get to 30%. So 2 times 3 is $6. So $6 is a better deal than $4. If we wanted to figure out the dollar amount for the second one, 1/4 of 20 means that we're going to take 20 times 1/4. 20 times 1 is 20, and then 20 divided by 4, since that's the denominator, is 5. So $6 is a better deal than $5 as well. Chris estimates $5,000 to purchase 6 computers at $789 each. Is the budget reasonable? Well, if I'm going to estimate and figure out if this is a reasonable budget, I'm going to round. And the one that I'm going to round is the $789. I want it to end in zeros so that it's easier to compute. So I'm going to round $789. And squiggly equals signs say about equal to. It tells you that your rounding is 800. So if I'm going to purchase 6 of them, then I have 800 times 6. Well, 8 times 6 is 48. And then I have 2 zeros. So the estimate that we would come up with then is $4,800 or $4,800, which is pretty close to $5,000. So it seems like a reasonable estimate, or it sounds like a reasonable budget. $5,000 is close to 4,800. Round to the nearest whole number. So we're looking in this case as if the decimal or fraction is more than a half, it's going to go up. If it's less than a half, it's going to stay the same. So 5/8 is more than a half. 4/8 would be a half. So 5/8 is more than a half. So the 4 is going to round up to 5. The decimal 0.119 or 199 is less than a half. So the 3 is going to stay a 3. And I should have put squiggly equals, like I just said. Squiggly equals means that you're rounding. It means about equal to. Estimate 8.25% sales tax on a $789 computer. So I'm going to round the 8.25% to 8, and then $789 to $800. So what is 8% of $800? Well, one way that we can do that is to say that 8% is 8 times 1%. And to figure out 1%, you move the decimal point one more place. When you do 10%, you move it 1. When you do 1%, you move it 2. So if I have $800, I'm going to move the decimal point 2 places over. So 1% of 800 is $8, and I need 8 of those. So 8% is $8, which is 1% times 8, or $64. And then the last one, write 0.24 as a reduced fraction and as a percent. Well, percent is easy. If I have the decimal 0.24, to figure out percent, I move the decimal place 2 places to the right. So 0.24 as a percent is 24%. And then as a fraction, the 4 ends in the hundredths place, the tenths is the 2, the hundredths is the 4. So if I'm going to write that as a fraction, it's the fraction 24 hundredths. Just like I would read it, 24 hundredths as a decimal. So now to reduce it, I'm going to recognize that both 24 and 100 have a factor of 4 that can be pulled out. 24 divided by 4 is 6. 100 divided by 4 is 25.